Hello, welcome to my video. I am Hoji, and in this video I'm going to show you how to solve a 2D static problem using this wonderful tool called 2D Structural Analysis Tool, or PermaLearn. So, here's a problem that we're going to be solving in this video. It's a problem asking us to determine the normal force, the shear force, and moment at point C. But before we solve this problem using this tool, let's go over some of its features. So here is what the general UI looks like. Right here we have our grid where we're gonna see our member. Basically, we're gonna see our problem in this grid. On the right side, we can adjust some things, like we can adjust the grid size. For this problem that we're gonna solve, you can see that the beam is 6 meters long. So we're going to leave the grid size 10 by 10, which means that the horizontal length and the vertical length, they're both 10 meters each. And mesh size, we're going to make it 0.5 to be able to select points easier. Because if we leave it as 1 meter, we can only select points at each corner of the grid. So we're gonna select our units. We're gonna keep it SI units because the units are SI in the problem as well. So now let's save options. Now, and then on the left, we can see the that we can add a member with this button. We can add a member. So the first thing that it's asking us for is the beginning x coordinate. Let's say it's 1, so that our beam doesn't start at 0 and it starts right here. And beginning y coordinate is also 1, so that we can see it easier, okay? And the horizontal distance from the beginning point. So horizontal distance from this point, it's 6 meters because our beam is 6 meters long, as you can see. There is no vertical distance. Let's add our beam. You can see our beam here. Now, you can also see some buttons down here, right? So we can edit our beam using this button here. We can like adjust some things if we made a mistake or something, or we can just remove it. But I'm not gonna remove it because I like it. Now the support. This with this button, we can add the supports that are in the beam. Right here, we can see that it's a pin support, right? And at point B, it's a roller. So let's add a pin at A. So join coordinate A right here. Now support type, pinned, and add. You can see a little arrow. It means that we added a pin here. And at B, let's add a roller. Roller. Yep. So now we have our two supports that are in the problem. And now we're gonna add the two forces. So we have 10 kilonewtons down, 1.5 meters from point A, right? Let's add that. Okay, let's quickly go over some of these functions. So we have an option to add a hinge. A hinge is kind of like a pin, but you add it if there is a hinge support in the middle of a beam. In this case, we don't have any like hinge supports, so we don't need this option for now. And joint load, it lets you add a force at a joint. Like these two supports are joints, right? We can add forces. We could add forces if we wanted to. For example, let's add a 5 kilonewton force down at joint B. Let's see. Oh, okay. So, I actually selected point A, as you can see here, but I can also add another force at B. Let's say it's also -5. So it makes it really easy to add forces at joints, but we don't need these two, so I'm just going to delete them. Now, point loads. This option lets you add a force at any point on the beam. So we're gonna select our member ID. It's just it just lets you select the member. We only have one member, so let's select it. And look, load orientation with the global coordinate system. It means like with respect to the whole coordinate system, and with respect to the local coordinate system, it means like let's say if your beam is like uh, positioned at an angle. This local coordinate system makes it easier for you to add loads perpendicular to the beam if it's not horizontal. But for this case, we're just going to stick with the global coordinate system. Okay, so the distance from the beginning point is 1.5 meters, right? We don't have a horizontal force, we just have a vertical force. And look, this arrow and a plus means that if a force is upwards, at least in this tool, it's positive. But our force is facing down, right? So it's negative 10. Negative 10 kilonewtons. Let's add it. Oh, yes. You can see it here, right? And the second force is 4.5 meters away from A. So let's add the second force. Distance from the beginning point, 4.5 meters. Vertical force, negative 15. Okay, there we have it. We have our two forces. And now, oh, there's another option to add a linearly distributed load. With this, we can add a distributed load. But we don't have a distributed load in this problem. But if you had one, you would select your member as usual. You would select load type, horizontal or vertical. If your load is horizontal, you select horizontal. If your load is vertical, you select vertical. And you can also select distance from beginning joint. Beginning joint in this case is A, right? Let's say 3 meters from the beginning point. And you can also select distance from the end point, let's say 1 meter. And it also lets you specify the beginning load. Like in a distributed load, you can either make it like bigger, 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 or like constant. Like every load at each in a distributed load, every force is the same, right? But let's make it like a triangle. The beginning load is 0, and the end load is, let's say, 5. Okay, actually, let's make it 1 kilonewton. Field load type field is not selected. Oh, we have to specify that it's a vertical. But yeah, as you can see, we have added a distributed load, but you can see that we said that it's just the beginning load is just 1. And if it's positive, it means that it's going up. But if we were to make it negative, it would go down. Like here. Yes. But we don't need it here because our problem doesn't have a distributed load. But if you were to have a distributed load, it's really simple to add it. And now, we don't need this option, at least in this problem. We also don't need this. We don't need this either. Okay, now the solution button lets you solve for unknown forces or reaction forces or normal forces, shear and bending moment. So here, normal, shear, and bending moment. That's exactly what we need in this problem. As you can see, they're asking us to find normal, shear, and moment at C. So now, unfortunately, we cannot select all at the same time, simply because it would make it really hard to, I think, identify which horse is which. So it makes quite a bit of sense that you can only select one at a time. So let's go ahead and solve for the normal force. Oh, okay, so when you select normal force, it shows you the normal force at each point, meaning that it shows you the diagram. So our point C is right in the middle. So let's select our point C, and you can see that normal force at C is 0. Now let's have the tool display our shear force diagram, and there we go. So it's the shear force diagram. and let's see what the shear force is at C. You can see that it's 1.25 kilonewtons. So our shear force at C is 1.25. And let's have the tool show us the bending moment diagram. There it is. And let's have the tool. Let's select point C, and you can see that moment at C is 18.75 kilonewtons. Now that is really useful. I'm not gonna lie. And now, um, oh, you have an option to display the bending moments in a reversed way. For example, here it makes it easier to see where you should make the beam thicker, which I thought was really useful. And thank you so much for watching my video. I hope that at least it was a little bit helpful for you, and I wish you all the good luck in the world and have a wonderful day.